Hi, in this video I will be showing you 11.7.1 of the practice final. Test the series for convergence or divergence. Sigma n varying from 1 through infinity n square minus 1 over n cube plus 1. We usually start off with test for divergence because that is the easiest test. If limit is n approaching infinity of a n is not equal to 0, then the series diverges. So we will check limit n approaching infinity of a n, which is limit n approaching infinity of n square minus 1 over n cube plus 1. We'll divide the numerator and the denominator by either n cube or n square. So this will become n square over n cube, which is 1 over n minus 1 over n cube divided by n cube over n cube, which is 1, plus 1 over n cube. So as n approaching infinity, this will become 0. This will become 0. 1 over n cube will become 0 as well. So it will be, you are left with 0 on the numerator, 1 at the denominator. So it's equal to 0. So we notice limit is n approaching infinity of a n equal to 0. So test for divergence in this case fails. So when you have a rational expression like this, if test for divergence fails, then the next option would be to either use comparison test or limit comparison test. So we'll apply limit comparison test. So we have to choose another series for which the convergence or divergence is known. So we will pick sigma bn to be sigma, the highest exponent of the numerator over highest exponent of the denominator, which is sigma 1 over n. This is a harmonic series, a p series with p equal to 1, or harmonic series which is divergent. So we have chosen a series for comparison, and that series is a divergent one. So now let's find out an over bn, and if limit as n approaching infinity an over bn is positive and it's equal to c, and if it is positive, then sigma bn and sigma an will behave alike, will converge or diverge together. So we'll see whether we're able to prove this result. So let's find out what the ratio is, an over bn. An is the nth term of the given series, which is n square minus 1 over n cube plus 1. And bn is the one that we have chosen, which is 1 over n. That is n square minus 1 over n cube plus 1 times n over 1, if you flip and multiply, which will be n cube minus n over n cube plus 1. So if you take the limit as n approaching infinity, an over bn, this will be limit n approaches infinity, n cube minus n over n cube plus 1. So limit n approaching infinity, n cube minus n over n cube plus 1. We are dividing the numerator and the denominator by n cube, which is the highest exponent of the denominator, which is limit n approaching infinity, 1 minus n over n cube, which is 1 over n square, divided by n cube over n cube, which is 1, plus 1 over n cube. So which will be 1 over n cube here. So 1 over n square approaches 0. 1 over n cube approaches 0 as n approaching infinity. So you are left with just 1 over 1. So which is positive. And this shows that sigma an and sigma bn behave alike. As sigma bn diverges, sigma an also diverges by limit comparison test. Hope this video